My name is Giuliano Campo-Marin, and my partner's name is Chester Soriano. We did our research paper on biodegradable polymer sutures.
For the introduction, suture would be a method to help the healing process of an open wound that is deep in the skin layers. In the BCE era, needles made from bones were used as a suturing method. There are properties that we must consider regarding sutures like tensile strength, tissue absorption, securing knots, minimized infections, elasticity, plasticity, handling, tissue reactivity, fluid absorption, and many others. In Figure 1, the flowchart shows the classifications of suture materials, which is divided into two sections of absorbable and non-absorbable materials. The background of biodegradable polymers. There is a big problem in the environment regarding the disposing of plastic waste that fights against microbial degradation. Biodegradable polymers are considered safer for the environment compared to their counterparts. Polyglycolide has a tensile strength 70 to 117 MPa, shown in Figure 2. Biodegradable polymers are classified in two groups, which are natural biopolymers and synthetic biopolymers. Applications of biodegradable polymers. There are many different applications for biodegradable polymers shown in Figure 3. For example, food packaging, electronics, computer keyboards, automotive parts, soil, organic recycling, and medical devices. Critical analysis of three articles. Article 1, fin element analysis of esophageal atresia repair with biodegradable polymer sleeves. Article 2, mechanical and in vitro studies of biodegradable tryptosan scissus quadrangularis coated flax sutures for anterior cruciate ligaments repair. Article 3, development of environmentally safe biodegradable antibacterial surgical sutures using nanosilver particles. Article 1, congenital esophageal atresia is a birth defect that causes discontinuity of the esophagus. The methods on this article were esophageal modeling an anastomotic retraction forces, and anastomotic sleeve. And Figure 4 shows the esophagus model and the retraction body forces. Article 1 results. Primary esophageal repair. The length of the suture located at the esophagus wall from the anastomosis affects the effectiveness of the Lagrangian strain, displacement magnitude, and strain energy density. Esophageal sleeve repair. At the anastomosis site, the high strain regions are reduced on the suture bite with the help of the sleeve. Long gap esophageal atresia repair. Long gap atresia also produce higher Lagrangian strain shown in Figure 5. Article 2. Flax fibers are biologic material that has biocompatibility with human tissues, which is useful as a suture material. The methods used were scanning electron microscopy, gas chromatography, mass spectrometry analysis, mechanical properties, hemolytic activity, and Figure 6 shows the braided flax suture.
The Article 2 results from the gas chromatography mass spectrometry. You can see that caffeine helps decrease fatigue, muscle relaxation, and relieves tension. In the scanning electron microscopy, seen in Figure 7, the scanning electron microscope shows two different magnifications of a raw braided flax suture. From the mechanical properties that were compared to the human ACL and flax suture were ultimate tensile stress, stiffness, yield strain, elongation, and simple knot pull strength. From the hemolytic activity, Out of the flax braided samples tested, the samples CHC-Q11 and CHC-Q23 are the most compatible to the hemolytic activity of the rubber and medical steel. In Article 3, where the sutures dealing with the nanosilver particles, which is an antimicrobial substance that is used in medical devices. Methods used in this article were electrospinning, tensile test, nanoindentation, transmission electron microscopy, and scanning electron microscopy, and antibacterial activity. In Figure 8, you can see the scanning electron microscopy, A, the nanosilver coated suture, and B, the uncoated suture. For Article 3 results from the electrospinning, you can see that after coating the suture with nanosilver, the flexibility improved with the help of the electrospinning method. In the tensile test and the knot pull test, the nanosilver coated suture had a tensile strength of 7.17 kgf compared to the suture that was not coated with 5.08 kgf. From the nanoindentation studies, the coated suture has better mechanical properties compared to the uncoated suture. In the transmission electron microscopy and the scanning electron microscopy, as seen in Figure 9, the SEM micrographs provide a uniform layer of the nanosilver on the surface of the sutures. In the antibacterial activity, the nanosilver helps the suture with antimicrobial activity and slows down degradation. Discussion. Congenital esophageal atresia, a biomaterial sleeve, helps reduce the anastomotic tension. Improvement of the healing process and risk of complications are reduced with the addition of a biomaterial sleeve. Coated flax sutures, the braiding technique of the flax fiber provides a better tensile strength, and there was cell growth on samples with cissus quadrangularis substance. In the nanosilver particles, improve the mechanical properties with the addition of polyethylene glycol. The uniformity of the coating is achieved by the electrospinning method, and nanosilver coating helps inhibit bacterial activity. Some of the issues with sutures today can be seen where surgical site infections are an issue when dealing with surgical sutures on open wounds. As you can see in Figure 10, this is a surgical site infection where the suture is overtaken by different bacteria, which causes the infection. And you can also see hypersensitivity. Allergic reactions have been reported after surgical procedures in which the tissue rejects the suture. The most common reported allergy is hypersensitivity to chromic catgut suture, which is a dermatologic phenomenon. Future works of biodegradable polymer sutures. To help lessen future surgical site infection cases, we add polylactide cholide acid, otherwise known as PLGA, with antibacterial substances to counteract the infections. PLGA is a biodegradable polymer that has biodegradability, biocompatibility, and toxicological properties. As for the antibacterial substance, a natural substance called totorol could be used to fight off infections. When we combine the PLGA and the totorol on surgical sutures, it will help prevent surgical site infections in the future. In conclusion, suture is a healing process of a deep wound through the closure of open wounds. The two classifications of suture materials are absorbable and non-absorbable sutures, with sub-classifications of synthetic and natural materials. Mechanical properties that need to be considered are tensile strength, elasticity, plasticity, knot security, tissue absorption, and others. Biodegradable polymer sutures have many benefits in the medical field, highlighted by the critical analysis of the 3 different articles we have presented. Issues to consider with biodegradable polymer sutures are surgical site infections and suture hypersensitivity, among others. Here are references, and thank you for watching.